All right, welcome everybody to your video lesson for today. We're going to be talking about 18.3, which is special products of binomials. We're going to start today on page 49, so if you are not already turned to page 49 in your packet, please go ahead and get there. We have a warm-up that we're going to start with, and so what we're going to be doing is practicing our box method of multiplying polynomials that we talked about last class. So if you notice here, I already have like my box kind of set up. I have it hidden under here. So go ahead and set up your box for the box method of multiplying these. And if the sub can pause the video, it's going to take them about 4 or 5 minutes here to work through these to get their final answer. So go ahead and pause the video. Everybody go ahead and work on the warm-up, and then we'll get started and see how you did. All right, so hopefully you've had some time to work through these problems. So the first one is a binomial times a binomial, and we have 3x plus 2 times 2x plus 5. So I have my 3x plus 2 set up on the left-hand side here. I don't know why it's not giving me my marker. Yep. The 3x plus 2 is set up there, and the 2x plus 5 is set up there. And so if I multiply the first two terms together, the 3x plus 2x, or 3x times 2x gives me 6x squared, and the 3x times 5 gives me 15x. If I multiply the bottom row, I get 2 times the 4x, which times 2x, which is 4x, and 2 times 5, which is 10. And so if I put that all together, one thing that you probably noticed last class and talked about last class was that if the binomials or trinomials, if the items that you're given, the polynomials are given, are in standard form, and we kind of have this diagonal pattern where we can combine those like terms. That's not always 100%, but it is true here. I can combine the 15x plus 4x, and that'll give me my final answer. I'll have the 6x squared plus 19x plus 10. So that's my first answer for number one. Number two, multiplying those together, this is what my box looks like, so let's get rid of that. X times x squared gives me x to the third, x times 2x gives me 2x squared, and x times 1 gives me 1x. Negative 3 times x squared gives me negative 3x squared, negative 3 times 6, I'm sorry, negative 3 times 2x gives me negative 6, and negative 3 times 1 gives me negative 3. Again, we have that pattern of kind of some diagonal-like terms here. So if I combine those, I end up with a negative 1x squared, and I end up with a negative 5x. And so that will be incorporated into my final answer. If I can select this and delete it. So we get x to the third, negative 1x squared, negative 5x minus 3. Okay? And then the last one, which is a monster, it's a 3 by 3. So we end up having 9 products initially, but we do have a bunch of simplifying that can happen. I'm not going to talk through it because it's a lot to talk through. You can kind of see what the box looks like. I will kind of circle the like terms. So we get x to the 6th in this direction, x to the 5th in this direction, x to the 4th this way. So we have a whole lot of like terms combined, and our final answer looks like so. X to the 7th plus x to the 5th minus 1x to the 4th plus 2x to the 3rd. And that is our final answer for that problem. So, that is what we talked about last class. Today, what we're going to learn are shortcuts. What we're going to learn today are some patterns to recognize when we can use some shortcuts to make this multiplication go a little bit faster, okay? When I show these to you, I'm going to show you kind of like the behind-the-scenes steps, what's really going on. And what I mean by that is it's kind of like still showing you what we would normally do when we multiply. But once we start recognizing the pattern, we won't have to do that. We get right to the answer pretty quickly. So let's start with the first one here. So again, I'm going to ask for the sub to pause the video here after I'm done kind of explaining. What we have here is a binomial times a binomial, and we have 3 different examples of that. So we have 3 different examples, example 1, example 2, and example 3. And if you notice, each binomial is identical. So 2x plus 3 times 2x plus 3, 3x plus 5 times 3x plus 5. And then we have like a general binomial where it's a plus b times a plus b, okay? What I would like you to do is to set up all three of these with your box method, just like I have already, like I'm going to show you. And when you're done multiplying, you should be able to notice a pattern that will allow you to kind of skip that box method of multiplying and go right to the answer in the end, okay? So pause the video for about 3 minutes or so, 3-4 minutes. Let students go ahead and work on these problems and then come back when everybody's done. All right, so hopefully you had enough time to finish up those problems. Now let's go ahead and take a look at what our box method reveals and if we can see any patterns that appear. So I'm going to go ahead and get rid of this box. What we should have gotten is a positive 4x squared plus a positive 6x, then another 6x, and a 9. So what we should notice here, and notice maybe it didn't make any difference preliminarily, is that these two terms are the same. We have a 6x and a 6x, okay? So that's my first noticing. I'm going to go ahead and reveal this one right away and see if that happens again. And what you should notice again is that we also have another term that is the same in both of these. So we end up with a 15x and a 15x here. So in both of the first examples, we end up having two terms that are the same, which means it's kind of like we have double of the same term. Double of the same term. Let's think of it that way. Okay. And then for the last one, for the generic one, does it also happen? Wrong button. I want to get rid of this box. We do, right? We end up having A times B, and we have two of those. Well, let's look individually at each of these boxes, okay? So if I look at just this one, where do I get that 15x from? Well, it's from multiplying 3x times 5, and this 5 times 3x, right? And I get two multiplications that are exactly the same. And it happens here. It's from multiplying A times B and then B times A. It's from multiplying those two things together. So we have a pattern that's kind of arising here. So when I write it all out long ways, I end up with 4x squared plus 6x plus 6x plus 9, okay? And that gives me the 4x squared plus 12x plus 9. In this one, I end up with 9x squared plus 15x plus 15x plus 25. So combining those, I end up with 30x in the middle, okay? And then the last one, I end up with two ABs in the middle. And when I put those together, I have exactly what I said, two ABs, okay? So that is the pattern that's happening. We end up with two middle terms that are exactly the same, okay? So let's kind of go through some answers here. Discuss and describe with your group any pattern you see in the problems and or answers. Well, the middle terms are the same. Okay, the middle terms are the same. The two middle terms, where you can add 2 here. Not there. The two middle terms are the same. We can add them together. They're the same. We get 2 of those, right? So it's like saying if the middle term was represented by the variable x, it's like we got 2 of those, right? Okay. So the other thing I want you to notice is the first term and the last term in each of these also has a pattern. Where am I getting the 4x squared from? Well, I'm getting the 4x squared from taking 2x times 2x. Where am I getting the 9x squared from? Well, I'm getting that from taking 3x times 3x. Where am I getting the a squared from? I'm getting it from taking a times a. That pattern is the first term is being squared. So this 2x here, if I take it and square it, if I didn't look at the rest of this and I just took 2x and squared it, I get 4x squared, right? If I just took 3x and squared it, I get 9x squared. If I just took a and squared, I get a squared. So that's the other pattern. Lastly, we also have a pattern for this last term. So take a look what's happening here. How am I getting this 9? Well, and let me clean this up a little bit. Get my eraser. How am I getting this 9? I'm getting it from taking the last term and multiplying the last term together. So 3 times 3 is 9. 5 times 5 is 25. B times B is B squared. So that last term is also a pattern. And all I'm doing is taking the last term and squaring that. Okay? So we got a bunch of patterns happening. When I take a binomial and multiply it by its identical binomial, we have a lot of things that happen. So let's kind of summarize these findings, right? So first of all, how could I rewrite each problem using exponents instead? So I want you to think about, like, well, if I take something and multiply it by itself, x times x is really what? It's really x squared, isn't it? Right? So my question to you is, how can I rewrite the first one? If I summarize this, I have 2x plus 3 times 2x plus 3. Well, that's no different than saying I have something multiplied by itself, which means I can square that, but I do have to put this in parentheses, right? So I have 2x plus 3 squared. So that would be my pattern, okay? So I can rewrite this as a squared binomial. Take a look at this one. I have 3x plus 5 times itself. How can I rewrite that as with exponents instead? Well, I can write it as 3x plus 5 squared. And again, that just means 3x plus 5 times 3x plus 5. And then the last one, I have that a plus b times a plus b. How can I rewrite that? Well, I can write it as a plus b squared. Okay, so what does that all mean? All that means is that once we recognize that we have this pattern here, a binomial, a plus b squared, I have a bunch of patterns that I can get. How is each first term related to what is in the problem? Well, we already discussed that in that first term where we have 2x plus 3 times 2x plus 3, that first term is really getting squared. The first term is 2x squared, which gives us that 4x squared. Same thing here. How is each term related? I can rewrite this. It's the square of the first term. Sorry, go ahead and I'll pause here for a second to let you catch up. How is each first term related to what is in the problem? The first term is the square of the first term given. The first term in your answer is the square of the first term given. All right, so back to the polynomials. This should say 3x. I'm going to get rid of this, 3x. 3x squared. I'm going to make this a little better. Erase this. Okay, so 3x is being squared, right? Because that's the first term being squared. So I can square that and I get my 9x squared, and that was the first term in our answer. Okay, in the last problem, and again, this should say A, not B. Not sure why I have A here, or why I have B. So I'm going to get rid of this. Write that as A squared, right? Okay, so if I square A, which is the first term here, I get A squared. That's the first term of my answer. Okay, how is the last term related to what is in the problem? Well, the last term is the square of the last term. The last term in my answer is the square of the last term in the problem. So let's look at the original problem up here. I have 2x plus 3, that's being squared. My last term in my answer was 3 squared, which was 9. If I look at the last term in the problem up here, which was 5, the last term in my answer was 5 squared, which is 25. And if I look at the last term in my problem here, identical binomial being squared, it's the answer is the square of the last term to get b squared. Okay, so kind of as an example, so well, I guess maybe I'll do this last one. I'll make up an example to kind of show you more. All right, now we got to look at the middle term in our answers, right? So let's kind of go back up to the middle term in our answer here. So now we're talking about, like, well, how do we get the 12 and the 30 and the 2ab? That's the first thing we talked about. That's the first pattern we noticed. Okay, how did I get that 12x? Not 12x. Yeah, 12x. How did I get that? It's because the middle term is equal to what? it's equal to 2 times the first term times the second term. So we got like 3 things being multiplied together. It's the number 2, it's whatever the first term is, and whatever the third term is. Those things multiply together. So 2 times the first term times the third term. That's how we get our middle term quickly. Okay? All right, so kind of is like spelling out everything. How did we get our middle term? We took 2 times 2x times 3. 2 times the 2x times the 3. If we go back up to that problem, the 2x plus 3 were the 2 terms that were being multiplied together, right? When we rewrote this as a binomial, we have 2x plus 3. All we got to do is take 2 times 2x plus 2 times 2x times 3. 2 times 2 is 4, times 3 is 12, and the x goes along for the ride, so we get our 12x. Okay? Let's look at our answer for the other middle term. I have 9x squared plus 30. Well, where does that 30 come from? It comes from 2 times 3x times 5. So if I go down here, I'm like, okay, 2 times 3x times 5. 3x times 5 is 15x times 2 is our 30x that we got, right? And then the last one, it's just 2 times the a times the b. So we get 2ab. Okay? So let's just, I'm going to make up an example here. Let's say I took, and this is how you will see the problems. This is how you'll see the problem. Let's say I took like 3x plus 5. Holy crap, that was the same example that we had before. All right, not that one. Let's get rid of that one. It's the same exact thing. Let's say I had 4x plus 3, okay? And I took that binomial and I squared it. If I recognize the patterns, I can come up with this answer without writing it out and without doing the box method, because I can follow these patterns and say, all right, the first term is the square of the first term in the problem. The answer is going to be x squared, which is 16x squared. Okay? Then my middle term is 2 times the first term times the second term. Well, that means I'm going to take 2 times 8x times 3. Well, 2 times 8x is 16x. 16x times 3 is 48x. And that's my middle term. And then my last term is what? The last term is the square of the last term. So the last term of my problem is 3, so I square that to get 9. And I got that answer without having to write out a box, without having to rewrite this as 4x plus 3 times 4x plus 3. And that's the advantage, okay? So let's take a look at summarizing this. So in general, if x times x is equal to, well, we know that's equal to x squared, right? Then a plus b squared is equal to a plus b times a plus b, right? This is the formula for the square of a binomial with addition. So I got a binomial that's being squared here, and there's addition on the inside, okay? So that pattern is this. That pattern is, my answer is we take the first term and we square it, okay? Then we take 2 times a times b, whatever a and b are, and that gives us our middle term. And then for the last term, we just take the last term of the problem and square it to get our answer, okay? Something that's nice to know but not necessarily required of you is that the result is a trinomial called a perfect square trinomial. And that name comes from the fact that we took a binomial and squared it. Okay? The result is called a perfect square trinomial. All right? So that's our pattern. what I would like you to do is to try to do problems 1, 2, and 3, and I don't want you to draw the box, okay? I want you to try to recognize using the patterns, and I have some things out here for you. So like in number 1, my A value, the first term of the binomial is X, and my B value, the second term of the binomial is B, all right? And so maybe you can think about what to do with the A and B in terms of this pattern that we just talked about, okay? So please go ahead and pause the video right now. Take about 3 minutes to work on these and then come back and see how you did. All right, hopefully you had enough time to kind of digest this and see how you did. So the pattern here is that, all right, my A value is X and my B value is, I don't know why I wrote B here, I just noticed that. I probably just forced a habit. It's not B, it's 4. Hopefully you all were like, what is he doing? Okay, B value is 4. And if we go back to our pattern, that means our first term is going to be the square of the first term, which is X squared. Our second term is 2 times X times 4, which is 8X. And our last term is the square of the last term, which is 16. So that is our final answer there. Okay, for this one, A is 3X and B is 2Y. And so our answer trinomial is the square of the first term of the problem. So 3x squared is 9x squared. Then I have to take 2 times 3x times 2y. 3 times 2 times, 2 times 3 times 2 is 12. 2 times 3 is 6 times 2 is 12. And then the x and y go along for the ride, so I got 12xy. And then my last term is the square of the last term of the problem. So 2y in parentheses squared is 4y squared. Okay, last one here on this page. Oh yeah, that's what I did there. So let's do that. For now, my first term is 4, my A value is 4, my B value is x squared. And so now I want to find my answer. So first term is the square of the first term, so 4 squared is 16. Then I have to take, for my middle term, 2 times 4 times x squared. 2 times 4 is 8, times x squared is 8x squared. And then for my last term, I got to take x squared in parentheses and square that, which gives me x to the 4th. Exponent rules we wrote earlier. And the only thing I did here is rewrite that in standard form, just to kind of give you a reminder. Remember, we write the highest exponent first. Not asked of you here, just kind of bring that back into life. Okay, so that is the first pattern. First pattern is if we have a binomial that is squared, then find our answer without doing the box method of multiplication. Then we can take the first term, square it, get our first answer. Take the 2 terms in the middle, multiply those together, and then multiply by 2. So 2 times A times B. And then the last term is just B squared, whatever that B value is. All right, so if you recognize that pattern, if you see problems on your quiz, wink, wink, nudge, nudge, you're going to, you can save a whole lot of time by just recognizing the patterns and going ahead and writing it out and writing your answer. If you sat here for the last 10 minutes and you're like, I have no idea what's going on here, Mr. Vesbach. This makes no sense. You can still rely on the fact that 4x plus, if I use this example, 4 plus x squared, and I take that and square it, then I have 4 plus x squared times another 4 plus x squared, and then go ahead and make your box and go ahead and multiply it out. You will get the same exact answer. It's just going to take you about 4 times as long. So whatever you prefer, it really doesn't matter to me, but these shortcuts will save you a lot of time and work and energy. Okay, so now we have a different pattern. It's the same idea, right? We have a binomial that's being squared, but instead of addition in the middle, we now have subtractions. We're going to get a little bit of a different pattern happening here, okay? So let's kind of think about this. So in your groups, make predictions without multiplying. What might happen when we multiply A minus B squared? use the following questions as your prompts. We will again get a trinomial for our answer. So I want the sub to pause the video, maybe only take a minute this time. So pause for a minute. Go ahead and try to answer these questions, and then we'll resume in a second. All right, hopefully you have enough time to work through those problems. Let's see how you did. So how is this different from the last one that we did? Well, it's different because now we have subtraction. And if my marker will let me write, there we go, subtraction. It's a minus b now, not a plus b. So will this affect the first term in my answer? The answer to that is no, it won't, because I'm still going to be taking a times a, right? So if we think about this as a minus b times a minus b, right? I'm still going to be taking a times a. So a times a is still a squared, so it does not change my answer, okay? Will this affect the middle term? The answer to that is yes, it will, because the middle term is supposed to be 2 times whatever a is times whatever b is, right? And the reason it's going to be affected is that b is now negative. So we can add the opposite here in both cases, okay? And now b is going to be negative. So now I will have not a positive 2 times a times b. It'll be 2 times a negative b, which is negative 2ab. So everything is essentially the same so far, except for now my middle term is going to be what? It's going to be negative. All right, will this affect the last term? Well, I'm taking a negative b and I'm squaring that, right? So if we follow the same pattern as before, to get our last answer, to get our last answer, or last term in our answer, we were going to take that negative b, whatever it was, right? And I got to put this in parentheses to make it right, and square that. Well, what does that mean? That means I have a negative b times a negative b, and a negative times a negative is what? Positive b squared. So will it affect the last term? Nope. It's going to be exactly the same as before. So what does that mean overall in our problem? What that means is that the formula is exactly the same except for this middle term. So when we were looking at this last time, right, this is our pattern from before, everything's going to be the same except for this addition. So let's go ahead and fill in our notes. So a formula for a square with a binomial squared with subtraction. So we have a minus b now. Our answer is a squared minus 2ab plus b squared. So it's the same as before. And for your information, the resulting trinomial is still a perfect square trinomial. So good terminology to know. Okay? So pattern's the same, except for now, I get a negative middle term. That's the only difference. So let's take a look. I'll maybe do the first one with you, and then you'll do 5 and 6, okay? So same exact stuff as before, right? I'm taking that first term, I'm calling it whatever a is, right? And a is now 5, b is now 6. It's just our first and second terms. And a is x, and b is negative 5. That's what that should be. And we should have negatives here. Right? These are all negative. All right, so now what are we supposed to do for our answers? Well, that first term has to be squared. Well, x squared is x squared, right? That's not no secret there. The middle term now is what's different. It's 2 times x times negative 5, which is a negative 10x. Okay, negative 10x. And then the last term is a negative 5 times a negative 5, which is a positive 25. Okay, so take maybe a minute to do number 5 and 6, and then we'll come back. All right, so we had enough time to work on those. Let's go ahead and see how you did. So in the first one, my a term is 6x, and my b term is negative 1. So what am I supposed to do? I'm supposed to take that first term square. What do I get? I get 36x squared. The middle term, I'm supposed to take 2 times 6x times negative 1. That gives me negative 12x. And then for the last term, it's -1 squared, which is a +1. Last one here, was kind of saving the idea of walking through it. This is what you should have gotten. You should have gotten 16x squared minus 24xy plus 9y squared. All right, so hopefully we're doing good on those patterns, doing well on those patterns. We have one more to talk about, and then we'll be done here. All right, next pattern is multiplying binomials, and this is different because now I have a binomial that has addition, and then it's the same exact binomial, except for now I have subtraction. So it's not a squared binomial because one has addition, one has subtraction, okay? So in your groups, discuss the following questions. How is this different than the last two types? Are we squaring a binomial? So I'm just going to pause here for 30 seconds and let you digest that. All right, that was about 30 seconds. So how is this different than the last two types? Well, the last one was a plus b squared, and the other one was a minus b squared. And they're different because they're not identical binomials multiplied together. They're not identical. They're almost the same, but one's addition and one's subtraction. Okay? So they're not identical binomials. Are we squaring a binomial? No, we are not. The binomials are different. No, they are different. Okay. So let's go ahead and talk about what our box method might look like for these. So what I would like you to do is go ahead and set up the box method for each of these. And then from those patterns, what we'll notice is kind of an interesting thing that comes together here. All right. So go ahead and set up your binomials, set your box method up, and then we'll see what happens. Okay. Go ahead. All right, let's see how you did here. So if I set up my box method for this, my box ends up looking like so. Oops, wrong one. My box ends up just like that, looking like so. Nah, selected all wrong stuff. Come on, get out of here. Delete. Looks like this, right? And so you might be curious about what happens here. What ends up happening is that my final answer is x squared. And if you look at these terms that are able to be combined, I get a 3x minus a 3x. And that does not give me 1x. That gives me nothing. But the middle term is gone in this case. And then my last term is just -9. So something happens here. I get some cancellation of terms. Let's take a look at the next pattern. Kind of the same idea happens. When I go ahead and multiply, I get 4p squared. Okay, but then I get a -32w and a +32w. Well, what happens with those terms? They also cancel out. So I get -64w squared as my final answer. That's the last term. So again, I lose a middle term. So let's generalize this. Like what happens if it's just anything, right? Does it happen for anything? So let's use our AB example. So again, the first term is being squared, so I get a squared. And then the middle terms here are opposite, and they do cancel out, and so I'm left with a -b squared, and I can write this as the opposite for my final answer. So what happens, right? In our own words, describe what you observe. Well, the middle terms, so the middle terms are opposite. So what does that mean? It means they cancel out. That happens every single time you get a binomial times a binomial, and the terms are exactly the same, but one has addition and the other has subtraction. That's what we get every single time. Okay, so let's summarize this in our formula chart here. So the formula for a plus b times a minus b, same binomial being multiplied by each other, one's addition, one's subtraction, is simply just square the first term, square the second term, and it's subtraction in the middle. This is called the difference of two squares. That's what this is called. This is called the difference of two squares. Okay, so now we got some practice, all right? So I would like you to pause the video, please. Go ahead and pause the video. Take maybe 2 minutes here to go ahead and finish up questions 7, 8, and 9, and then we'll come back and see how you did. Pause, please. All right, so hopefully you had enough time to finish these. So let's see what you got. So for number 7, you should have gotten, again, square the first term, square term 7, so you should have gotten 49. And square of the last term is x. X squared is x squared. So you should have gotten 49 minus x squared. Number 8, square the first term. X is the first term, so square that, you get x squared. Second term is 6, so you should have gotten negative 36. 6 squared is 36. And number 9 is slightly more complicated, but also still very doable. The first term here is x squared. So if I square x squared, I get x to the 4th. And then the second term is 2y. If I square 2y, 2y squared is 4y squared. And then I end up with subtraction in the middle because it's the difference of two squares. So hopefully you did an excellent job on those. And now what we're going to do is kind of summarize all of that information here. All right, so let's go ahead and summarize that information. So special products. These are the 3 things we talked about today. If you have a binomial squared with addition in the middle, our pattern is a squared plus 2 times a times b plus b squared. So we take the first term, square it, then we take 2 times a times b, and then we take the second term, square it, and that's our answer. We do not have to do the box method. We can get our answer right away. In the second one, where we have a binomial that's squared, but we have subtraction in the middle, that is also a perfect square trinomial. We get almost exactly the same result, except for the middle term is now negative. So we take the first term and square it. A times a is a squared. We take 2 times a times b, but because b is negative, we get negative 2ab, and then take the last term and square it to get b squared. And then the last one that we talked about, if we have 2 binomials that have the same terms, but one is subtraction, one's addition, one's subtraction. This is called the difference of two squares, and that middle term just drops out, and then we get the square of the second term, right? So we end up with a squared minus b squared. So we just take this, square it, take that, square it, shove subtraction in the middle, done. All right. We have some mixed practice that I would like you to work on. This should only take you a couple minutes, so I'd like to pause the video, the mixed practice, and then we will be done for the day. Pause the video, please. All right, so hopefully you had enough time to finish those. Go ahead and check your answers. So for the first one, we should have gotten 9x squared minus 42x plus 49. This is a squared binomial with subtraction in the middle. So we square the first term to get our 9x squared. We square the last term to get our 49. And then 2 times 3 times 7 is 42. 7 times 3 is 21, times 2 is 42. But it's negative because of subtraction in the middle. Number 11 here, we should have gotten 4x squared plus 20x plus 25. Square the first term is 4x squared, square the last term is 25, and then the middle term is 2 times 2 times 5. 2 times 2 is 4, times 5 is 20, and the x goes along. So, and it's positive in the middle, so we get a positive answer. Number 12, we should have gotten 16 minus 4y squared. This is two binomials that are the same, but one is being added, one's being subtracted. So we square the first term to get 16, square the last term to get 4y squared, and it's subtracted in the middle. And we have the same exact pattern in number 13. Answer you should have gotten is 25x squared minus 4. All right. So those are the answers you should have gotten at the end here. We got a couple more examples and then we'll be done. I kind of erroneously said this was the last one. We have one more very important problem that we need to cover. So bear with me here. Number 14, why does a plus b squared not equal a plus b? Well, for example, if I have 3x squared, that means I'm squaring what's inside parentheses, right? So what do I end up with? I get 3x times 3x. So similarly, if I have a plus b that's being squared, then that means I have a plus b times a plus b. I can't just jump here. This is not the distribution of exponents like we've talked about in the past. Okay, it's not the same. This gives us 9x squared, by the way, because I multiply 2 times 1 and 2 times 1 to get 3 squared, and x squared, and 3 squared is 9, right? But because we have addition in the middle, it's not the same. Okay, this, as we know, gives us the a squared plus 2ab plus b squared, and it's not the a squared plus b squared. Okay, so that's why it does not equal that. Hopefully you finished that in your warm-up as well. Okay, last problem here. Let's go ahead and get started. Okay, so Troy wants to make a square garden with a concrete walkway all the way around it. He is undecided on how large to make the sides of the square garden below, but below represents the binomials he's using to determine what the sides are. So we have x plus 9 to represent this, and we have x minus 2 to represent that. And if it's a square, then what we should remember is that, a square is all the same side. So this is also x plus 9. Right? And then this is also x minus 2. X minus 2. Okay? So the sides are all the same for the individual squares. So write an expression for the area of the concrete walkway. The concrete walkway is what is going around it, right? So basically what we want to do is we want to take the large square and we want to delete the middle, right? It's kind of like a square donut here, and we want to get rid of the middle, okay? So we're going to take the whole area, and we're going to subtract the garden. And that's going to be equal to the walkway around it, right? So the whole area is going to be the area of the large square. Well, what is the area of a square? Area of a square, you might initially think is length times width, right? But when the sides are the same, then we can say that, well, it's really side times side. And so the area is really a side squared, okay? So if I want to know the area of the whole thing, then I'm going to say that I have x plus 9, and I'm going to square that, okay? And if I want to know the garden walkway, well, I have to do the same thing. I have to take the x minus 2, because it's a square, right? It's x minus 2 times x minus 2, or x minus 2 squared. And in the end, I have to take those two quantities and subtract them. Well, if you notice, these are each of our patterns, right? I have a binomial added, or with addition in the middle being squared, and I have a binomial subtraction in the middle being squared. Using our patterns, we can find the answer to these quickly. X, the first term is going to be, the first term of the problem, squared. So I get x squared. Plus, then it's 2 times x times 9. 2 times 9 is 18 times x is 18x. And then the value of the last term is the last term of the problem squared. 9 squared is 81. And it's going to be that minus the answer to this. All right. Well, if I take x minus 2 and I square that, I get kind of the same pattern, right? I'm supposed to square the first term. X squared is, well, x squared. The middle term is 2 times x times negative 2, which gives me a negative, I'll write it as negative, 4x. And then the square of the last term is going to be negative 2 squared, which is positive 4. Okay, so now I got to take these and combine like terms. All right, well, I have subtraction here. So I have to distribute a negative. So that means that this positive x squared will become negative. This negative 4x will become positive. And this positive 4 will become negative. And now when I combine like terms, my x squareds actually cancel out. X squared and x squared are gone. Okay. Then I have an 18x and a 4x that can be combined into a 22x. So my area is now equal to this 22x. And then 81 minus 4 is equal to 77. This is the expression for the area of the concrete walkway. So now what do we have to do? Part B, it says, all right, if x was 10, what would be the area of the walkway to the nearest foot? Well, what are we going to do with this 10? That's going to go right in for x, right? So I'm going to say area is equal to 22 times 10 plus 77. And that 22 times 10 is 220 plus 77. And so that means the area of the walkway is 297 feet squared. Why does this matter? Well, if I was going to be ordering concrete, I would want to order the exact amount. And this is a common pattern where you have concrete around something, right? And so I would be able to tell, I would use this for a cubic yard calculation, but at least it'd give me a starting point, right? So I need 297 square feet of concrete. All right, so you should have some work time right now. Good job today, and I hope you have a great weekend. Peace.